Hello students, let us continue with chapter 12 electricity. Now in the previous video you have seen what is Ohm's law, its statement and activity to prove Ohm's law. You know the mathematical form of Ohm's law, V is equal to IR. You have also learnt the definition of resistance, qualitative as well as quantitative definition and its definition of its SI unit. Now let us just have the recap of the resistance part. You know, resistance of any material is the opposition offered by it to the flow of electric charges through it or to the flow of electric current through it. So it is a kind of opposition. And if we talk about its quantitative definition, V is equal to IR. So R is equal to V by I. Accordingly, you can give its quantitative definition by using the formula R is equal to V upon I. Now let us see an activity which will prove that different components have different resistors. Now for this, you have to connect the circuit as shown in this circuit diagram. Here I have a 6-volt battery, a key, ammeter. See, the ammeter positive is towards the positive side of the battery. And here XY, these two terminals are open. It means the circuit is not closed. Okay, there is air gap between X and Y. And thus, although the key is closed, I have not shown the direction of current because the current will not flow as the circuit is open. Either when the switch is off or the circuit is broken or any device is damaged in between, which is present in the circuit, then the circuit will not work, no current will flow. Now in your textbook, instead of this 6-volt battery, they have shown this symbol of the battery where we have a battery of 4 cells and each is having potential difference of 1.5 volts. So you can use this or you can use this, it is not going to make any difference. So set up the circuit as shown in the figure using the connecting wires and using the devices given here. Now here I have shown 3 different components. One is nichrome wire. You know nichrome is an alloy. One is torch bulb. One is bulb of 10 watt. Torch bulb usually has low power like 1 or 2 watts. Okay, so these two are bulbs, but this is the torch bulb which is having lower power comparatively, maybe 1 or 2 watts. So what we'll do, suppose if you connect the circuit as shown in the circuit diagram, you connect first nichrome wire here in this gap XY. It means you connect the nichrome wire, it's one terminal to here X and the other end to the Y. So then the circuit will be closed. Obviously when you do that, you will take the key out and then connect it and then you will insert the key. Okay. So when you will do this, you have to note down the ammeter reading which will give you the current flowing through the nichrome wire or through the circuit. Okay. Now next what you do, you remove the nichrome, you switch it off, remove the nichrome wire and connect torch bulb and again close the key. Again note down the reading of ammeter. So it will give you current. Similarly, you can replace the torch bulb by bulb of 10 watt and note down the reading of current in the ammeter. So you are repeating the experiment 3 times, noting down its current every time, first by using nichrome wire, then torch bulb, then bulb of 10 watt. You will see that each time the current reading is different. So every time you change the component, the reading shown by ammeter is different. It means current flowing through the circuit or through these components, the currents are different. So here we are not changing the battery. It means potential difference is same across the nichrome wire or across torch bulb or bulb of 10 watt. We are not changing the power supply. We are not changing the potential difference across them. But still current is changing. So V is equal to IR. If V is constant, I is changing. It means resistance I and R, they are inversely proportional. If current varies, it means the resistance also varies. So here using this activity, we can prove that as the current reading is different in each case, So different components, they have different resistance or they offer different opposition to the flow of electric current through them. Now in NCERT, you have these sentences, actually 4 sentences you have. So I'll just explain you what do they actually mean. First of all, remember, you are considering 4 different components which are having same dimensions of same size. Okay, so 4 different components having same size, let us consider same shape. So if a component out of the 4 components, the component of a given size that offers a low resistance, we can say it is a good conductor. A conductor having some appreciable resistance means which is going to actually affect the value of current there, is a resistor. So resistor is what? A conductor having some appreciable resistance, and in this case we are considering that all the components are of same size and we are comparing their resistance and giving them names. A component of same size, identical size, that offers even higher resistance will be poor conductor, and again a component of same size that offers even higher resistance than the third case is an insulator. So it means when you have different components of same size and their resistances are different, you can just compare their resistances and say one is which is having very low resistance is good conductor, having some appreciable resistance more than this is a resistor, having higher resistance is poor conductor, even higher resistance is an insulator. Okay, so I hope this is clear to you. So they are actually comparing the resistance of the different components having the same shape but they are of different material. Now we have seen that different components have different resistance. Their opposition to the flow of electric charges are different. Now, what is the factor which is responsible for this, or what are the factors on which resistance depends? So, we are going to see now an activity to just know the factors on which resistance of a conductor depends. But before we do this, you should know that actually what is responsible for electric current flow through a conductor, or let us say through a metallic conductor, flow of free electrons. When electrons flow through any material or flow through a conductor, they are not, path is not very smooth for them. It is not that they don't face any opposition. While moving, they collide with ions and other free electrons or atoms present in the material. So this collision results in opposition. Okay, so while moving, when they collide with ions, other free electrons or atoms of the material, this results in resistance or opposition. And different components, they offer different resistance. So let us see factors on which resistance of a conductor depends. For this, consider the circuit. Here it is erased. I'll just put a line. This was just erased by mistake now. So consider the circuit as shown in the figure, as shown in the circuit diagram. So have a look at the circuit diagram first. Here we have a cell, here an ammeter, a key, these are connecting wires. And I have numbered here 1, 2, 3, 4. There are 4 different components. Okay. So first is a nichrome wire having some length, let us say L, and cross-sectional area A. So first is a nichrome wire which is shown connected in the circuit now. Second is again nichrome wire but whose length is doubled. This is again a nichrome wire but whose length is doubled than the first wire and thickness is same. So cross-sectional area is same. Third wire is also of nichrome. Length is same as the first wire but it is thicker. You can see it is thicker. So A dash is the area which is different than that of first and second wire, and I have written that it is thicker. It means A dash is greater than A. Fourth is not nichrome wire. It is a copper wire of some other material. So we have chosen here copper as given in NCERT textbook. This is having same length, same thickness or cross-sectional area as that of the first wire. So now you know what are these first, second, third and fourth components which are shown in the figure. So you have to connect the circuit by first connecting the first wire and closing the key, and you have to note down the ammeter reading. It means you will note down the current. Let us say the current is I. Then you will open the circuit, remove the key, disconnect first and now connect the second wire. Okay? And when you will connect the second component here, again close the key and repeat the process. Note down the current reading. It will be observed that current reading is reduced to half. It is half of the previous reading. What is the change here? The change is only of length. Length is doubled and we have seen current is reduced to half. Similarly, when you repeat this by connecting third and then fourth component, it will be observed that when you connect the third component, which is thicker than the first, then in that case current will increase. So here I will increase means it will be greater than this I. Okay? And in the fourth case, when same length, same thickness is used but different material, like here copper wire is used, it will be observed that I changes, current changes. It means it is not same as that of A. So from this activity, we can, conclude that current changes when we change the length or when we change the thickness, or when we change the material of the nature of material of the component. And if the current changes, it indirectly means we know that current is inversely proportional to resistance. So if current changes, then resistance also changes when length changes, thickness changes and material changes. Now since I is inversely proportional to R, so let us see here what happens to resistance when the length changes, thickness changes and nature of material changes. We know that from this activity, as the current changes, we can conclude that resistance of a conductor depends upon its length, its thickness or cross-sectional area and its nature of material. And precise experiments and measurements were done, and then afterwards it was concluded that, now it is stated that, so we can conclude that as current is inversely proportional to resistance, from this observations, here we have seen that when the length increases, current becomes half. And it was, as I have told you, precise experiments or measurements show that resistance is directly proportional to length. So when the length is doubled, resistance gets doubled, and I is inversely proportional to resistance, so it becomes half. Second, resistance of a conductor is inversely proportional to cross-sectional area of the conductor. So when the cross-sectional area increases, resistance will decrease and current will increase. And in fact, if we use a wire which is having double thickness, if the cross-sectional area is doubled, resistance will become half and the current will be doubled. So when we combine the two relations, that resistance is directly proportional to L, it is inversely proportional to area, cross-sectional area of the conductor. When we combine the two, we can write R is proportional to L by A. And when we equate, as we usually do, we will multiply the right hand side with the constant. In this case, the constant is denoted by this symbol, which is read as rho, R-H-O, rho. So capital R is equal to rho L over A, where L is length of the conductor, A is cross-sectional area of the conductor, R is resistance of the conductor, and rho is a constant of proportionality, which is called as resistivity or electrical resistivity or specific resistance of the material of the conductor. So rho is resistivity of the conductor. Now, can you guess what are the factors on which rho will depend? As you already know, resistance depends upon four factors: length of the conductor, cross-sectional area of the conductor, nature of material of the conductor. If you remember, when I stated Ohm's law, I have told you one more factor, that is temperature of the conductor. So there are four factors on which resistance of a conductor depends, and we know that this here in this formula we have length and cross-sectional area, but the other two things are missing. So we will study further about this resistivity in the next video. Hope the activities that we have discussed today, which proves that different components have different resistance, factors on which resistance of a conductor depends. To find these factors we have discussed the activity. So hope the activities are clear to you. We'll continue with resistivity in the next video. Thank you, students.